you hopefully remember these notes on exponents and logarithms that you took down. Now we are adding one piece to that. This one right here. Everything else on this page you already have in your notes, but add this one piece to it because today we're going to be focusing on this part of our notes over here and how we can use those for simplifying equations with exponents and expressions. Alright, so to use this information, to use those two parts of the notes, we're going to be focusing on problems like these today. Basically, simplifying expressions that involve negative exponents and fractional exponents. Fractional exponents, by the way, also called rational exponents because a rational number can be written as a fraction. Write down that first problem. And we're basically dealing with one of the ultimate potential confusions right off the bat. The combination of negative and fraction in our exponent. And the reason why we're going through this is because you've already been seeing questions that involve some of these aspects. But a lot of it has been kind of developing your own strategies. And that's fine up to a point. But if you can't ever find a really good strategy that's working for you, that could be problematic. So this is kind of a chance for me to talk through some of those strategies. All right, for this first one of those strategies that I always employ is I try to deal with negative exponents first. And so in this particular case then, I'm going to take that x to the 11/4 and deal with the negative by putting it into the bottom of the fraction. Because remember, a negative exponent flips it in the fraction. Now that I've gotten it to this point, I'm going to deal with the 11/4. That turns it into a radical, right? So that's going to become 1 over, we got an x inside. Now which root is this? Is this the 11th root or the 4th root? 4th, good. Yes, it's always the number on the bottom. And then inside is the top. The numerator is our exponent on the x there. So we have 1 over the 4th root of x to the 11th. We're not done yet. Because, for one thing, we can simplify that radical there. Okay? So, let's actually go ahead and simplify that radical. So this is going to be 1 over... Okay, so how many sets of 4 can I pull out of 11? 2. So x squared. And then that leaves 3 more. So I still have the 4th root of x cubed there. Alright, and we're still not done yet. Yeah, because remember that we cannot leave a radical in the denominator. So I need to multiply top and bottom of this by a radical such that the radical on the bottom is going to go away. So now the question is, what is that? Because sometimes people get thrown off by this because of the cubed and the 4th root and stuff like that. A way to think of it is, if you have x to the 3/4, what do you want to add to that 3/4 so that you just get x to the 1? And so that's why, yes, it is 1/4. And so 1/4, of course, that is the 4th root. So it's just going to be 4th root of x that I multiply into both the top and the bottom. And so when I do that then, on the top I'm left with that 4th root of x. And on the bottom I have x squared times, well, the 4th root of x cubed times the 4th root of x gives me just x. And so, yes, one last step. That gives us the 4th root of x over x cubed. And that would be our final answer. And remember, I acknowledged, yes, this is starting off with the hardest that you might see. Seeing how to deal with that combination of negative and fractional exponent all together. Alright, so having done that one, now let's go back to our original set of problems. Go ahead and give the next two a shot on your own first. Oh, and yes, you should be able to do that last one without a calculator. So for the second one then, we're doing the cube root of x to the 7th. So we're looking for how many sets of 3 can I pull out of 7. And we can pull out 2 of them. So that ends up being an x squared with how many left over?
1.
1. So that x inside is just an x. It's not x to the power of anything because it would be x to the 1, hence x. So this would be our simplified answer there. The next one over, yes, you should be able to do that without calculator. And the trick to it is seeing how we can rewrite the bottom. Because 27, notice the top is 3 to the power of something. 27 is 3 cubed. So my 27 cubed is actually 3 cubed. That's a lot of 3's. But if I keep going with that, on the bottom, when I do a power to a power like that, so I have this setup right here, remember that means to multiply those two exponents, so this becomes 3 to the 9th on the bottom. Then it's just a matter of simplifying those, so the 7 over 9 gives me a negative 2, so it's 1 over 3 squared, which then, of course, just equals 1/9. So you work through each of these problems first, and then we take a look at them together, because I now want to kind of give suggestions, so that as you work through it, if there was anything that you found awkward, then maybe I'll give you a hint here that tells you maybe an easy way to deal with it, whatever, we'll see. In the case of this first one here, there's multiple ways that people approach it. Some people will start by doing 4 plus a negative 5 minus a negative 3. You can get away with that. However, I will say that depending on what all is happening, that could lead to potential error just because you're doing so many things all at once. What I always like to do whenever I have those negative exponents in there is I get rid of the negative exponents first. So I have a big old fraction. The 2b to the 4th, that's still on the top because there are no negative exponents attached to those. But this b to the negative 5th, well, that becomes a b to the 5th on the bottom. And the b to the negative 3rd on the bottom, that becomes a b cubed on the top. Because remember, a negative flips the bottom to the top or the top to the bottom. Now we can go ahead and combine those. Now the 2, notice, is unaffected by any of those exponents. So I can do the 4 plus the 3, which gives me 7. And if you want to write that down as an intermediary step, of course it's a great way to keep track of your work. But we end up then getting a final answer of 2b to the 2nd power. So 2b squared.
2b to the squared.
All right. Middle problem. And in this case, you got a couple choices, but really, it gives me an opportunity to point out my favorite way of dealing with some of these. When you see a negative exponent, I still like to deal with it first. This negative exponent right here, I'm going to deal with that and only the negative part at the moment. And so, the negative part of that just flips the bottom to the top of my fraction and the top to the bottom of the fraction. Nothing else is changed along the way. But by flipping it, I just dealt with that negative part, which is the part that makes it more complicated. So it's no longer as complicated. Now, there's nothing else inside that I can simplify first. Sometimes there is, in which case you have a choice of doing that first. But now we're going to cube. Power to a power means multiply. So on the top, that's going to become x to the 9th.
It's just a negative value.
Now on the bottom, the part that's going to trip most people up is not so much the y, because that becomes y cubed, but it's the negative 2. Notice that basically what we're doing here is we are doing a negative 2 cubed. Notice our exponent is still positive, so it doesn't flip it in the fraction. But the number itself is negative. Okay, so if you cube a negative, do you get a positive or a negative?
Negative.
You get a negative. Okay, so I'm going to get a negative, and 2 cubed, of course, is 8, so it's a negative 8. And so then that would be your final answer. Or if you want to clean it up just a little bit, you might have written that negative as applying to the whole fraction. Yes, that would equal the same thing because it's only in the bottom. And then for this last one, the last one is very similar to some of the work we did earlier. I'm going to go ahead and start by, well actually, I'll give you a different way of looking at it this time. I'm going to start by multiplying top and bottom by a radical in order to make this part become just a whole number, because that cube root of y to the 5th, remember, is the same as y to the 5/3. I want this 5/3 to become a whole number. So, it looks like 5/3 plus 1/3 will give me 6/3, which is 2. So, I can multiply the top and bottom then by just the cube root of y. And if I do that then, I end up with 7 cube root of y over y squared, which is your final answer. And yes, you could take multiple steps in that. You can go ahead and simplify the radical first and then multiply top to bottom. That's perfectly fine. In fact, it's what I would expect most people would do. However, it's always good to see different techniques. All right, so then having done those, I just have one more problem for you to do. So the great part about this problem is that it incorporates all of the same stuff we just talked about and just used. So just do anything you can see to do and just keep working it through one rule at a time, one piece at a time, and you'll get there. The very first thing I chose to do is just use that negative that was applied to the whole parentheses. So all I did was just flip it upside down, left everything else untouched, but just flip it upside down, use that big old negative outside.
I did that too, Mr. Ward.
A good thing you can do after that is go ahead and deal with all the negatives on the inside. And actually, I miswrote one thing here. That should just be a b, not a b to the negative 1, because I used the negative.
Wait, what about B to?
All right, and so I just used all the negatives in there. I also did one other thing here, by the way. The 20 over 15, I went ahead and reduced that, so divide top and bottom by 5. That's where we got the 4/3. And then I keep going from there. Looks like I can still do some simplification inside. These b's on the bottom, even the a's, I could do those, or I can square everything. I'm going to wait to square everything. I'm going to simplify inside first. And that's a choice. Different people make different choices as far as some of that stuff goes, so go with what makes sense to you. All right, now, at this point,
Oh, I messed up.
this a to the 4th over a to the 9th, I'm going to turn that into an a to the 5th in the bottom. Oh, I should make room for that 3 there as well. Okay, but then I still have this cube root of a to the 10th on top. The cube root of a to the 10th. Well, how many sets of 3 can I pull out of the 10? 3, with just 1 left over. So then I can turn that then into a cubed times the cube root of a. Okay, on the bottom, let's see here. I still haven't dealt with those b's, so I have a b to the 8th. And I still have the square root of b there. So all that stuff is squared now.
I think I messed up again.
Okay, we're getting closer. You know, I ended up creating a situation where I got one more thing I can simplify though inside. So I'm going to go ahead and do that.
Wait, wasn't it?
Because that's going to be 4 cube root of a over 3a squared. B to the 8th root
Okay,
b.
good. Oh, I'm like,
All right, we're getting there.
Did you have a B to 17?
Let's now square this
I
out.
didn't know if it's either the same.
Next up, we're going to square everything inside. Now, when you square everything inside, remember to square the numbers as well. So the 4 squared becomes a 16, and the 3 squared on the bottom becomes a 9. Oftentimes, we forget to actually square those. So make sure you do that part. Now,
To divide 20,
we have the cube root of a that we're going to square.
everything else.
So if I'm going to do the cube root of a squared, that can just become the cube root of a squared. And then on the bottom, the a squared squared becomes a to the 4th. The b to the 8th squared becomes b to the 16th. And the square root of b squared equals b.
BB.
Yay.
Which means then that I don't have a whole lot left I can simplify.
Yeah, it was.
We end up with 16 cube root of a squared all over 9 a to the 4th b to the 17th.